Hello, welcome to SEPAM. I'm Orisheje Matthew. Today we are going to look at the solution to IGCSE Paper 3, Variant 3, May-June 2025. So let's go into this question. I'm going to just do a quick review of all the questions. So let's see. So this is the entrance. So we have the paper is just for 1 hour 15 minutes. Okay, so we'll look at the question 1. So let's make it a bit bold so that we can have a proper view. So this shows the speed time graph for two racing cars. So we have car X and car Y. So the dashed line is for car Y, and then the bold line is for car X. So using the information, state and explain which car X or Y has a greater acceleration between 2 seconds and 4 seconds. So between 2 seconds and 4 seconds. Well, to be able to answer this question, you know that the car that cover more distance within a shorter time is the one that have higher acceleration, or the one that is the slope is very steep. So if you look at these two of them, so car S is moving faster, has a higher acceleration because it has a higher slope, while the car Y is gentle. So the answer to that question is racing car X. Okay, so let's look at the next question. Give reason for that. So if we want, what's the reason? Racing car X has a steeper slope. Now determine the speed of car Y at 10 seconds. So what is the speed of car S at 10 seconds? So what we are going to do, you go to the graph and then go to this graph. So if you look at this graph, at 10 seconds, you can draw a line to make contact with the car, and then we can now trace it to the speed axis. So that gives you the speed. So it's 24 meters per second. So let's go down. So what is the time there? The speed is 24 meters per second. That is the speed of car Y. Determine the distance moved by car S from 0 to 4 seconds. So go back again to the graph. So we'll look at it from 0 to 4 seconds. So the distance moved by the car is equal to the area under the graph. So just identify the shape. So let's see. So if you look at it from 0 to 4 seconds, the car X, so if you look at it, it's a triangle. So once you calculate the area of this triangle, first of all, you identify the height and then the base. The base is 4 seconds. Then the height is, so you read the value there, and then we can now use it to calculate for the distance travel. So now another thing again we want to look at, if you are looking at velocity time graph, speed time graph, when the graph is horizontal, means that the moving object is moving with a constant speed. So for car S, between 4 seconds and 12 seconds, it was moving with a constant speed of 22. And then if the slope is straight, that means it's moving with a constant acceleration. So these are the things you need to understand. And then when the object is moving with constant speed, the acceleration is 0. So when VT graph is parallel to the time axis, the acceleration is 0. So we just have to use the opportunity to revise what you need to know about velocity time graph. So let's go and answer the question, distance travel by that car. So bring it there. So let's bring the parameter. The height is 22 and the base is, so the distance travel is equal to, so if you make that, so let me make it bigger. So what is that? So you can see the distance travel is equal to area under the curve, which is equal to area of triangle. So if you do that, so the distance is 44 meters. So now let's go to question 2. If you look at question 2 is about show the direction of 4 forces acting on a racing car. So you have this car here. The force that is making it to move forward, which is known as the driving force. Then we have the force that is acting upward. This is the normal reaction. Then C, acting downward, which is the weight or the contact force. Then the drag force, the resistance that is moving it backward, or the frictional force. So we just identify those major forces. Then if you look at the first question, is describe the forces. So just write the name. So what are the forces? So you have those name there. Then the driving car is decelerating along horizontal track. The value of force D is 2,800 Newton. So what suggests a value for B? Now look at the major point that we need to know. There's a statement that is given there. And what is that statement? The statement is that okay, I wanted to show you this, so let's see. Okay, the car is decelerating. So let's see, the car is decelerating. If the car is decelerating, that means it is reducing speed as time increases. So if the car is decelerating, what is going to be, that means the drag force is greater than the driving force. So when they say subjective value and they have given you the drag force, that means the driving force is lower than the drag force. That's why the speed is reducing. So suggesting a value, so we have that. So if 2,800, so the value have to be less than 2,800. So anything you put then less than that value will work, provided it's not 0. So I just have to illustrate this. The car is moving to the right, which is the driving force, which is green, and then the frictional force is greater, so it will slow down. Okay. Now, so let's go to the next question. The question 2 is, if you look at question 2, some building are built on a large strong metal rod that push deep into the ground. So a machine drop a heavy hammer onto each metal rod to push it into the ground as shown. So the crane is used for driving this strong metal into the ground. So find the weight of the hammer is that is 25,000 Newton. That is the hammer is 25,000 Newton. Calculate the mass of the hammer. So this is just a simple question. So you know that the relationship between weight and mass. So let's just make it bigger. So what is the relationship between weight and mass. The weight of an object is equal to mass multiplied by acceleration due to gravity. So mass is equal to weight divided by gravity. And on this question, we asked to use 9.8. So if you do that, that will give you 2,551 kg. But we have to approximate our answer. IGCSE, you have to approximate your answer to two significant figures. So approximating that will give you 2,500 kg. So that is the answer to that. Okay, the next one is the machine lifts the heavy hammer through the height of 0.5 meter, that is 75 cm vertically. Calculate the work done in lifting the hammer. So, and include your unit. The work done is equal to the weight multiplied by the height. So that gives you that value. So, or you have the mass, which is, this is the mass of the object, 2,500 multiplied by acceleration due to gravity. So it's just equal to, work done is equal to the potential energy. So if you do that, so you get that the work done is 70,640. Then express that to two significant figures, that will become 18,000 joule or Newton meter. So you have the unit. The unit is either 2,000 joule, 18,000 joule. The unit of work done is joule or Newton meter. So you write down that value there. Okay, if we look at question C, the heavy hammer fall onto the metal rod and push it into the ground. Describe the energy transfer from the heavy hammer to the rod. Your answer should refer to energy store as well as transfer between energy store. So the hammer, when the hammer is lifted up, that is potential energy, and then as it drops rapidly, the potential energy is converted to kinetic energy. And then when the hammer makes contact with the strong rod, then it produces a sound energy. It becomes hot, so thermal energy, and then it pushes into the ground forcefully. So you are pushing the particles of the ground rapidly, so it makes them to move faster, and then the temperature rises, and then sound is released. So because energy cannot be created, or so sound is produced. So we have this 4 stages of energy transformation. So let's go to the next question. Question 3. We have to move a bit faster so that the video will not be too long. So in question 3, guys have to look at the principle of moment. So if you look at this, let's make it a bit bold so that we can, okay. So if you look at this, a student determined the weight W of a metal block by using a 1.5 Newton load on a uniform meter ruler. She places the center of gravity of the ruler on a pivot, so at the center, so the weight of the ruler is not contributing to the movement of the meter rule. So he put a weight, the known weight is 1.5 Newton. Then he wants to find the weight of this metal block that is placed 0.21 away from the pivot on the right hand side. So this weight is going to produce clockwise moment, while this known weight to produce anti-clockwise moment. Now calculate the weight W of the metal block using the principle of moment in your answer. So let's say, so what is the concept here? We know that what clockwise moment equals to anti-clockwise moment. So let's get the anti-clockwise moment. Anti-clockwise moment is the force acting downward multiplied by the distance, the perpendicular distance from the pivot. So we have the force multiplied by that, so that will give 1.5 Newton times 0.44. That is the anti-clockwise moment. So multiply it out. That is 0.66 Newton meter. Then this value is equal to the clockwise moment. So clockwise moment is equal to the weight, the force is W, multiplied by the distance from the pivot, 0.21. So that gives you 0.21 W. So solving this simple equation, anti-clockwise moment equals to clockwise moment. So make W set of formula that will give you the weight of 3.14. So approximately to two significant figure, that will be 3.1 Newton. Okay, so a different bus lying on the ground as shown. So the weight of the bus is 890 Newton. Calculate the pressure on the ground caused by the block. So pressure is equal to force per unit area. So all you need to do, calculate the base area of this block, which is 0.18 multiplied by 0.54 meter. Then divide it by the weight of the bus will give you the pressure. So that would be, so divide that out. That is the pressure, which is 9,156.3 Newton. So approximately that would be 9,200 Newton per meter square. Now let me just give you a clue here. You see, assuming you have forgotten the formula of pressure, look at the unit given to you. The examiner have given you the unit, and once you are given the unit, they have given you a clue how to calculate the formula of pressure. So the unit given to you of pressure is Newton per meter square. So Newton is what? Force, and meter square is area. So you just use that, and then you know that pressure is equal to F over A. So from the unit you can get the formula. That's why physics is easy to pass. Right. So let's go to the next question. So let's go to the next question. So we look at question 4. Question 4 is about, so let's make it a bit bigger. I say complete the sentence about the kinetic model of matter. Okay, so let's see if we want to make it, I want to make it clearer so that you can easily see it. Now, complete the sentence about the kinetic model of matter. The movement of the particle in gas is what? It's rapid, it's random. So the particle move randomly. So then the force between the particle in gas is weak. So it has a weak force. Then the gas exerts pressure because the moving particle collide with the wall of the container with one another. As the temperature of a fixed volume of gas decreases, as the temperature of a fixed volume of gas decreases, what happens? The particle move slowly, and then the rate of collision reduces, and then the pressure reduces, because pressure is directly proportional to the rate of collision. So the higher the collision, the higher the pressure they exert on the wall of the container. So there's going to be a decrease in pressure. State the value in degrees Celsius of the lowest possible temperature, that is negative 273 degrees Celsius. That is, we call the word ice point. Now state the term used for the lowest possible temperature is called the absolute zero. So this question here is just your ability to recall basic facts about physics. So that is all about this question here. So next, let's go to question. We go to question 5 rather. So question 5. Okay, your instructor produced a water wave in a ripple tank. So it's about waves. So let's see this question on wave. Okay, your instructor produced a water wave in a ripple tank. The wavelength of the water wave is 1.2 cm, and then the speed of the water wave is 18 cm per second. Calculate the frequency. So this is a direct question. The relationship between velocity, frequency, and wavelength is velocity is equal to frequency multiplied by wavelength. So you have that. So make frequency subject of formula. That gives F is equal to V over lambda. So substitute. And since the two units here, you are given cm per second and cm per second, so there's no need to convert it to the SI unit. So use it the way you are given. So that gives 15 Hz. So that is it. Hz means 1 per unit second. Now, so let's go to the B part of the question. Figure 5.1 show a red light passing through a prism and emerging into the air. So you have air to glass to air. Now state the name of the process shown in figure. So this is refraction. What is refraction? The ability of light to vary its direction as it moves from one medium to another. So that is refraction. Now, so let's look at the B part. A ray of white light passes through the red light as shown in figure 5.2. The ray of white light splits into different colors. So you were given the answer already in the description. Okay, draw on figure 5.2 the dispersion of white light. So what is dispersion? When white light is incident on a triangular prism, the white light split into its different color. Okay, and the one with the fastest speed is red, which is going to be at the top, and then the one with the slowest speed is going to be violet. Okay, will be at the bottom, and then in between here you have the simple way to remember this is Röykbeef: red, orange, yellow, green, blue, indigo, and violet. But you are only, you say, label the red and the violet. That is a purple part of the spectrum. So this is for doing this, you have 3 mark. So what is the 3 mark? For getting the direction of the red, 1 mark. Getting the direction of the violet, 1 mark. Then for getting the spread, the way the light, the red light and the purple light are deviated, that will give you the next 3rd mark of this particular question. So let's go to question 6. We are making progress, so let's just go. You can actually go through the video, maybe question by question, for you to have a better understanding. So this time we're talking about right, you have to look at temperature and then transfer of energy. So if we look at this, so let's make it magnified. Now, so your instructor used this equipment, okay, shown in figure 6.1. So you have a shiny surface and then a dull surface. So we're going to look at, actually it's just to test the rate of energy radiation. Okay, shiny surface are good reflector, while dark surface are good emitter and absorber of heat. So because this thermometer S facing this is going to get hotter, while this one receive more radiation, while this one on the shining side, when you pour hot water into this bottle, the heat will be reflected back into the bottle, and then the radiation going out here is lower to thermometer Y. Thermometer S and place at the same distance, yes, that is to keep the experiment. We want to make sure that the variable, which is the distance, is a control value. Then the room temperature is 20 degrees Celsius. The instructor pour very hot water into the bottle. Now after 5 minutes, okay, so let's see, after 5 minutes, okay, now reading the thermometer, explain why the reading. I've already explained that. Now suggest a value for the reading on that. You say that the room temperature is 20 degrees Celsius, and then the reading on thermometer S is 24 degrees Celsius. Now thermometer X, look at it, thermometer S is the one facing closer to the dark surface, while thermometer Y is the one close to the shiny surface. So look at it here. Now the reading of thermometer Y, the reading on thermometer Y is not 24 degrees Celsius, but that of thermometer X is 24 degrees Celsius. Now since both thermometers are receiving different amount of heat radiation, that is infrared, that means the temperature rise is going to be different. So, and the one that receive less radiation is going to have lower temperature, and the one that have highest radiation will have a higher temperature. So if thermometer X is having 24 degrees Celsius, so the thermometer here will be slightly lower. So any value between 21 to 23 will suffice for this answer. So so you can write any value, 21 degree, 22 degree, 21.5, 21. So there's the range. Within this range, any value that you write is acceptable, but provided the value is not up to 24 degrees Celsius. So question, the B part of the question. So let's just make it larger so we can read it. A student demonstrates convection in a liquid. The student has a water supply and the following equipment: a candle, a glass beaker, a tripod, and so these materials are given. So you have the crystal, you have the tripod, you have the beaker, you have, okay. So what will you do? Describe how the student can demonstrate convection in a liquid using the equipment shown in figure 4.2. So the first thing is you put the crystal inside the container. So let's look at the diagram. This is what you are going to have. So you want to show this diagram. So you have the beaker, then the convection. When you heat it from the bottom, the hot water rises because the density reduces, and then the cold water at the top have higher density, and so the density drops down, so creating this flow current of hot water rising up and cold water falling down. So what will lead to this convection? So first thing, put some crystals inside the beaker, then pour your water, then place the beaker on the tripod stand, then next heat the water and observe the convection produced by the current. So question 7. Okay, question 7 is about wave. So let's make it bigger. Right. Now put a tick to show the property of sound wave. Now sound wave is longitudinal wave. Now longitudinal wave, the vibration of the is parallel to the direction of propagation of the wave. Okay, so then microwave is electromagnetic wave. So electromagnetic wave is a transverse wave. It's electromagnetic and travel in vacuum. But sound wave cannot travel in vacuum. Sound wave is not a transverse wave. Sound wave is not an electromagnetic wave. Sound wave cannot travel through vacuum. You need material medium. So sound wave is a mechanical wave. But electromagnetic wave is not a mechanical wave. Okay, because it travels without medium. Now, scientists have placed reflector on the moon. Scientists use the reflector to measure the distance between the Earth and the moon. Okay, so you have a ray of light is sent from the observatory to the travel there and travel back. So the distance traveled by the ray of light is twice the distance between the Earth and the moon. A scientist send the red light, then the reflector send it back. It takes 2.5 seconds for the light to travel to and fro. The speed of light is 300 million meters per second. Calculate the distance between the observatory and the reflector. So this is just reflection. So what you need to do is take note that you need the distance, because the light is going to travel twice the distance, that is 2d, is equal to velocity times time. So we have the velocity times time will give you the distance. So the distance, the speed times the time, divided by 2, because the light traveled twice the distance in this time given to us, 2.5 seconds. So if you carry out your division, that gives 3.75 times 10 raised to the power 8 meter. In other words, that is about 375 million meter. Now, state one use of ultraviolet ray detection of fake banknotes. Okay, security check, and then it's also used for sterilization. State one harmful effect of that. So we have damage to gene and damage to skin. So you have other effects, but they just state one of them. Okay, so question 8 is on electricity. Very good. Okay, just let's magnify it so you can read it very well. Now, so figure 8.1 show the main power electric fan heater fixed on a bathroom wall. Okay, if you look at this, the question is a pull cord, that is to on it, is used to on and off the heater. Suggest why a pull cord is safer than a push switch for a fan heater in bathroom. Now the reason is, you know, the wall is wet, and then when you are using the bathroom, there's a tendency of water splashing all around. So once it gets wet, and water is a poor conductor, and then it also has the tendency of producing electric shock. But when you pull this rope, which is an insulator, is not a conductor, and so pulling it prevents you from being electrocuted or receiving shock in case of short circuiting. Okay, so with that is to reduce the risk of being shocked. Now this shows the electric circuit for the heater. So here S is the fuse, this is the power source, this is the switch, and then this is the heater, and then this is the electric motor that blow the fan, the air. So identify the parts. So we've already done that, the fuse and the motor. Then the next question is, this information show the power of the heater is 2 kilowatts and then the voltage is 230 volts. Calculate the current supply by the heater. Power of a heater is equal to the voltage multiplied by the current. So power is equal to IV, and then we are looking for current, so that is power divided by voltage. So if you do that, that will give you 8.696 ampere. So but express your answer into single figure, that is 8.7 ampere. So question 9, very good, we are making progress. So it's also on electricity. So okay, now 9.1 show two resistors connected in series. Calculate the combined resistance when resistors are connected in series. In the lab, you do that to produce a higher resistance. And how do you get that? You just add them together. So this is a giveaway question. So 60 ohm. Then two resistors are connected as shown in this circuit, and then you have the ammeter. The reading of the ammeter is 0.2 ampere. Calculate the potential difference across the 20 ohm resistor. So what the current flowing in a series circuit is the same current that passed through the 20 ohm that passed through the 40 ohm resistor. So the PD across a resistor is the current multiplied by the resistance of the resistor. So that will give us the value of IR, which is 4 volts. Then how do you get the voltage across this one? Since there are only two resistors, the voltage add together to give you the total voltage powering the current. So if the 20 ohm has 4 volts, then the 40 volt is going to have 4 plus 8 to give you 12 volts. So the voltage drop across the 40 ohm resistor is going to be 8 volts. A student used a voltmeter to measure the potential difference across this. Okay, show how the voltmeter is connected across the. So the symbol for a voltmeter is a circle with a V written inside it. So and then it's connected in parallel when you want to use it. So it's connected in parallel. So that is a connection. So you have your 2 mark. So let's go. Now see the student remove the 2 resistors and connect them in parallel as shown. So when resistors are connected in parallel, what the resistance reduces, and then the resistance that is produced is always smaller than the smallest resistor in the parallel connection. So any value less than 20 will be this answer. I say suggest a value for the combined resistance of the 2 resistors. Suggest a value. They didn't say the actual value, but any value less than 20 is correct here. But let's show how do we calculate it. Let's just review how to find the resistance of resistors combined in parallel. So you just take the reciprocal of all of them. So the total resistance 1 over R equals to 1 over 20 plus 1 over 40. Solve that. So you have 3 over 40. Take the reciprocal of both sides. So that will give you 40 over 3 divided, that is 13 points. So this is the actual value, but you just write anything. Okay. Question 10. Wow, we're making progress. Okay, so let's make it bigger. This is on atomic physics. So nuclear physics. So radium-222 is a radioactive gas that emits alpha particle. The nuclide notation for radium-222 is 22286 radium. So if you look at this one, so we have the mass number, and then you have the atomic number here. So 86. Calculate the number of proton. Number of proton is equal to the Z number, which is the atomic number. So that is 86 proton. Determine the number of neutron. So just subtract 86 from 222. That is 136. A sample containing 600 milligram of radium-222 decay to 7.5 milligram in 11.5 days. Calculate the half-life. So put at it that. So from 60 to 20, half. That is the first half-life. Second half-life, the mass reduces to 15. Second half-life. Then third half-life, the mass reduces to 7.5. So how many half-lives are there? 1, 2, 3. So that 3 half-life add up to 11.5. So what is one half-life? One half-life is going to be 11.5 divided by 3, which is 3.83 days. So to significant figure, the answer is 3.8 days. Now, question C. Radium gas is one source of background radiation. Okay, name 2 other sources that make significant contribution to the background radiation. So in the room where you are measuring the half-life of a radioactive material, there are about 6 possible material that are responsible for background radiation. So you have the rock present, you have the building, you have food material, you have drink, and then you have cosmic ray. So these are the various sources of radiation, but just 2 of them is enough for you to get all the mark. So let's go to question 11. So this question shows the solar system. You have the sun. So most time, okay, in the year 7 class, there is just an easy way to make students to remember the order of the planets from the sun to the last. So I'll normally say MVE, MJS, UN. Okay, let's just make it bigger. You can see it on clearer. Okay, so if you have this, so what complete the missing label? Okay, okay, my very elegant mother just serve us noodles. All right, so I hope you got that. So my very elegant mother just serve us noodles. Right, so you remember the planet there. So now the sun consists mainly of 2 elements. Name them: hydrogen and helium. So those are the raw material that carry out the nuclear reaction in the sun. Nuclear fission. Okay, the sun radiates energy mainly in 3 regions of the electromagnetic spectrum. Ultraviolet is one of them. What are the other 2? Infrared and visible light. So the last question. Good. Cool. We're here. Last question. Okay. Scientists use the Big Bang theory to explain the way the universe began. State one piece of evidence that supports the Big Bang theory. You talk about the redshift. Now, what does the redshift mean? That the ray if a light that is sent to spectrum, you discover that they tend to have a longer wavelength, okay, because of the motion, the expansion of the galaxy. So the motion, the relative motion, and then the wavelength, that the reflected wavelength tend to have a longer wavelength. So now scientists use accretion model to explain the formation of the solar system. Complete the following sentence about the accretion model. In space, there are clouds of dust and gases. The materials spin around and move closer together due to the force of gravity. Now, this form an accretion disk. So this brings us to the end of this question. All right, subscribe to Super Easy Physics and Mathematics. Thanks for reviewing it. Stay tuned and remain studious.